هنا the exercise, I'm gonna just remove this. Okay. So the exercise احنا قلنا assume an average car in the United States gets 20 miles per gallon of gasoline, is driven 12,000 miles per year and weigh 3,500 pounds. So furthermore, assume that the gasoline weight is 5 pounds per gallon. 5 pounds per gallon يعني هذا this is the density, and contains 85% carbon weight. So is there any truth to the statement that each car emits its own weight in carbon dioxide each year? Okay, so هنا we said first of all, since the car can run or can roll 20 miles by using 1 gallon, so the consumption is 1 gallon every 20 miles. That's why I've written this way. Okay, so هنا 1 gallon per mile, per mile. The car weighs 3,500 pounds. The density is 5.9 pound per gallon. The proportion of carbon is 85%, and this is a weight proportion. Yeah, that means that if you have 1 kilogram of gasoline, it contains 0.85 kilogram of atoms of carbon. And you suppose physically that the combustion operation is a full reaction. So it means that you are converting the totality of your gasoline. In the practice, we know that small proportion is would be evaporated, etc. Yeah, there are some very small quantities that you can that we are neglecting in our logic here. So هنا, is there any truth? So this is the assumption. They are telling you, is it true that each car emits its own weight in carbon dioxide each year? Not in carbon, but in carbon dioxide. It means that you should calculate the mass of carbon and convert this in number of moles, and you calculate the mass of CO2. It's not in terms of mass of carbon, but in terms of mass of CO2. Because in the book correction, he calculated the mass of carbon. It should be the mass of carbon CO2. Otherwise, he should change the exercise in mass of carbon. This is important. That's why I will not give you the same correction in the book. Even in the digits, we don't have the same accuracy in digits. That's why you should rely to yourself. Sometimes in the books, there are some cookies. So let's do this first. So let's verify this assumption. هل السيارة تنتج ثاني أكسيد كربون أكثر من وزنها ولا قد وزنها في السنة ولا لا؟ هذه هي الفكرة ولا لا؟ ماشي. احنا جينا هنا في الأول ايش قلنا؟ يعني هذا اوكي مارك داون انتهينا منه. بعدين by the way, this markdown, if you click out like this, for example, we're gonna come back to this. Or if you run it, if you run, for example, here, this is your text. It's small. I'm gonna show you the way how to enlarge the text. And if you want to color your text, you can do it. It's easier. You can do it. You just even here, for example, if exercise 1, if you want to put it as a title, you can do it. By the way, in a mark here, you can do it. You can do so, and by using a dièse, I think. If you run it, you have this kind of title. It's not the same in the code. In the code, if you add a dièse, it means you are commenting. Here we added dièse to comment, so it's not the same. It's not the same function. Normally in Python programming, this is not programming language. This is not Python. This is almost similar to HTML, the markdown. But the code, the real code is this one. Is this part? The code part. This is the real code. So anyway, I just want to tell you that you can do nice things, yeah, even with the text. Even the size, you can play with the size. You can come here, for example, write like this, like in HTML. You can write font. هنا مثلا size equal 4, okay, and close it, and you come here, you copy this one and put it here, for example, and you do anti-slash font. So if you do like this and you run this markdown, you see now the size is large. You can play with the size. You can even impose the color. Even by line, the color, you can play with it. This is the text. I don't care about that. I'm caring about the code. What is important for you is this part. But I would like to tell you that even there you can write beta. I don't know, and it's you can write beautiful text. You can add images. You can do everything you want. So I want to come back to my exercise. My car consumption is 1 gallon per 20 miles. The weight is 35,000 pounds. The density is 5.9 pound per gallon. The proportion of carbon in 1 liter or 1 pound of gasoline, 85% in terms of weight. And vehicle mile traveled, 12,000, so 12 E3. And so if I would like to calculate the annual car consumption, I wrote it like this. The annual car consumption is gallon per mile multiplied by the number of yeah, here I can add this number of vehicle miles traveled. Okay, okay, traveled. Okay, so like this, I'm calculating here the annual car consumption in gallon. Okay, so that's why I can write it like this. It is better. Okay, so I define a string, SS, and this string, I write the annual gasoline consumption of a car is equal one digit. Double point means that if you, because you can have a lot of input there, and you can, for example, if you have annual car consumption, the consumption per gallon, the consumption, and you will put, you will define them with, and here I can write 0, by the way, because it is in the position 0. You can have a lot of variables. Variable 1, variable 2, variable 3, and this variable should appear in your string. Okay, you can write like this, or you can write without 0, because you have already one variable, so you don't need. So, and what is here is the precision. 2 digits, 1 digit, it depends on, it's dot 1, it means 1, F means float. صح ولا لا? Okay, so, and I am printing this string, okay? So if you run this, it will appear like the annual gasoline consumption of a car is the value in sorry, not in pounds, in gallon, gallon per year. And after this, you should convert this gallon per year in terms of weight in pound. So you should divide by the density. You should divide by gallon per, you should multiply by pound per gallon. So, like this, you will have the simplification, because this is pound per gallon, raw gas. So I calculated the year mass as the annual consumption in gallon cross pound per gallon, اللي هي 5.9. So like this, I have my result, and I will write this result in terms of pound per year. So if I run this code, normally I have this. I have 600 gallon per year, and I have 3,000. Now, if you want to convert this in kilogram, you should just go. You have two options. The first one is you create your own library of constants. All the physicians do this. All the people working in chemistry do this. Yani all the constants, you don't need to. Another option is to go directly to, for example, Google, and you Google it. So I'm gonna write here goes this. I'm gonna convert it, so I can come here and write. My constant, I will put it here. So I'm gonna call it LBS. No, kilogram per pound, equal to. Here I'm gonna write as a comment how many kilogram per pound. So sorry, this. So like this. I'm gonna take this one. By the way, if you don't wanna to write, so this is in kilogram per year, and if you want, you have two options. You can take this value and rewrite here, for example, year mass gas consumed in kilogram, and you take this variable and you make a multiplication. And if the name is kilogram, you can write kilogram like this and tab, and it will appear, and you do enter. So this is, if you have a lot of variables, you can, and your code is, and you have many parameters up, or if you are importing them from another file, just write the beginning, a tab, and you will see all the variables. Any variable you imagine in your head. For example, SS is what? Is a string. If you click point, you will see all the functions or method called method of a string. شوف. Center, count, find, format, map, is decimal, is digit, is numerical. All these are functions related or linked to the class string. So same thing for real values, for float, for everything you want. So this is SS. I'm gonna call it SS2. This is SS. This is SS2. This is my variable I would like to show. I think I overwrote something. No, I overwrote. I should keep this one. Like, and I copy this here, and I will call this variable SS3. تمام. هنا in kilogram per year. I can keep this calculation here or move it if you want to script your script to be more organized. Just when you come back to it, it is more visible. بين قوسين يعني to be honest يعني you can even also write the whole code and you print at the end. يعني كل البرنتات هذه انا ممكن اسحبها في الاخر. وهذا المنطقي اكثر يعني تخلي الحسابات في الاول what you want to show to people at the end, because by the way, in the practice what you are seeing in the output of any software is this part. You will not see this. You will not see this. It's hidden in general in the script or in the exe file. But here we are using Jupyter just to interact with your code. Yani, this is interesting. Why? Because you can use later on Google Colab. Google Colab is exactly Jupyter with a small difference. You know, sometimes you need to add a exclamation point to execute a command. يعني there are some slight details فقط. It's the same thing. كأنك تشتغل على Jupyter. So I'm gonna call it SS3. هنا SS3 and the variable is the result in kilogram. If you run this, this is your result. Is it correct? If you do the calculation, if you did the calculation manually, I don't know if it is okay for you. I don't know in the book what is the value, because there are some difference between me and I found some difference sometimes, especially when, but I can verify it. Here in the book, it's given about. Would like to make a post to not. Now, this is 1,605 kilogram per year of gasoline. This contains about 85% of carbon. So the mass of carbon emitted per year I'm gonna say here, for example, I can add SS4. I can calculate the mass carbon. C mass or M C C mass. I'm gonna say right mass carbon emitted equal to this mass in kilogram. Okay, ضارب البروبورشن هنا. we define this proportion of carbon in terms of mass اللي 85%. I'm gonna do this, or I can do like this P. so يديني كثير من الاشياء صح. ولو كتبت P capital R تطلع لي الاشياء اللي اوكي. I take it. Yes. tab tab تطلع لك if you oops if you do it like this, for example, PR tab. So you have two things. You have the statement and you have this. This is a process class. Okay, so this is what is in green is a function. Your variable are written in brown. So I'm gonna take this one. I click. I take it. So I do my calculation and I just want copy the text. Maybe I copy all this. So I'm gonna the annual mass of carbon emitted by a car is هنا هحط this. I'm gonna put this result. Huh? Yes. Tell me. Yeah. By the way, even if you keep it, it will work. لأنه he will overwrite the old one. فهمت؟ هيحذف القيمة القديمة ويحط الجديدة. يعني ممكن كلهم تسميهم اس، ولكن يعني it's up to you. This is I don't wanna يعني إذا تبغى شغلك مرتب سميهم مختلف. They will not change a lot in the memory. They will not take a lot of space. يعني if you do it, just do something يعني well organized. It's better for you later on when you want to come back. And I'm gonna tell you the truth. Every time I come back to a script I did sometime 1 week ago, I should reread to remember, because sometimes it takes time. So if you run this, this is the mass of carbon emitted. Now, if you want to calculate the mass of CO2, this is the mass of carbon. For example, in the book here, when he did the calculation, I don't know where is the calculation. The carbon emitted, yeah, he did correctly the calculation here. And despite he did the correct, because this is the mass of carbon. You should calculate the mass of CO2. So from this mass of carbon, you should calculate the number of moles emitted per year, and you multiply this by the atomic mass of CO2, which is 12 plus 16 cross 2. صح ولا لا؟ So let's calculate. Let's write just here that هنا atomic mass of carbon MC12. So this is 12 gram per mole, and for the CO2, maybe I can write it like this just to make it nice. Here MCO2, so it is 12 plus 16 cross 2 صح ولا لا؟ 16 cross 2 32 32 plus 12 48. So I'm gonna write 48. Okay. Why it is better to write 48 than because I don't need to make an operation every time I run my script. Okay, but you can, it's up to you. Even if you do it like this, it will not change a lot of things, because this operation is not really time consuming. Okay, I'm gonna keep it like this for you, just to remember that this is C plus 2 O والO هي 16 gram per mole. So what I'm gonna do here is mass of CO2 هنا mass of mocha ولكن C. I'm gonna write it C. It's the carbon emitted. هنا C. Okay, so if we will calculate the mass of CO2 is the mass, so the mass of CO2 is equal to the mass of C emitted. So if you take the mass of carbon emitted and you divide it by the atomic mass, you will find the number of moles. But you should take care, but because the mass we have here is in kilogram, and we are dividing by something in gram. But this something in gram will be simplified because I'm gonna multiply by something in gram also. اللي هي 48 gram per mole for certain. So for that, I'm gonna just take care about this, and I know you will. So I'm gonna divide like this. Normally you should adjust the problem of unit. يعني يا اما المقام يعني تضربه في 10 قوة إلا 3 ولا البسط تضربه في 1000. Oh, this is لكن هنا because we're gonna in all the cases it will be a certain simplification. MCO2 divided by MC gram per mole will be simplified. So we don't have any problem here. Because you will divide by you multiply by 1000, you will divide by 1000. Okay, so now finally كيف وين اي غيرتها هذه لازم اي وين اي مال 16 12 جرام كربون. اي هذه الكربون، يعني الكربون اكتبها بهذا الشكل حتى تفهمني اكثر دقيق. الكربون يعني 1 كربون تمام plus 2 oxygen. Just to remember that you have in CO2 1 carbon 12 gram per mole, 2 oxygen 16 جرام per mole ضرب 2 ضرب 16. التعديل هو هذا 2 ضرب 16. بعدين هنا I'm gonna write that SS5 أو my print my last print هنا that هنا this one here and هنا SS5. So the mass of CO2 emitted by a car is, and the result is how much? 5,000 kilogram per year. I don't know how much. He have 11,000 pounds. We can do the calculations. And if you want to calculate this in pounds, and or I can add it here, and I can convert. So here, if I would like to do this, or I should add 0 because I will point on this value, and I'm gonna copy the same result. Okay. The only difference is that this will be pound. So in my calculation, I'm gonna or maybe I can do it like this: 0 1 تمام. وهنا I'm gonna put 2 variables, the mass and the mass divided by ايش قلنا احنا هنا عشان divided by kilogram per pound to find my result in pound. Okay. Here. Okay. So if you do this and you run it, you find 11,033. وكم لقى 11,040. there's a very small difference between both of the results. في الكتاب عنده 11,040 أنا لقيت 11,033. This comes from rounding. اوكي في النهايه لقى 11,040 هو عنده انا عندي 11,033. anyway this is for the concerning the question of. So now I'm gonna write another thing. The mass of the car. I'm gonna show you an if command. So I can do it, and even if I change the values it will give you always the good result. If look this is if يعني إذا if هذه القيمة اللي هي الماس of CO2 emitted وين احنا القيمة اللي عندنا هنا بالكيلوغرام ولا بالباوند؟ بالباوند. I can compare it with مع القيمة بالباوند أو أحول هذيك للكيلوغرام. It's up to you. if الماس of the car يعني الكار weight هذه weight car less or equal to or less it depends يعني how to will write this. If it is less than this mass اللي هي ممكن انا اخدها بهذا الشكل ده. mass of CO2 emitted in pound equal واحسبها واخذ هذه احطها هنا تمام في string حتى ما اثقل عليه يعني تجي مرتبة اكثر وخلاص اصير استعملها بعدين use it here. So if this mass is less ترى I can even leave this cell. I can create a new cell but I'm writing everything in the same cell. It's up to you. So مرات الناس تبغى تكون مرتبة أكثر تكتب جزء كبير من الكود في سيل بعدين الستيب اللي بعدها في سيل ثاني. يعني مثلا هذه ممكن أنا ايش أسوي؟ خلاص آخذ هذا الجزء كله تيست وأسحبه هنا وأجي وين؟ وأجي هذه مثلا أسويها مارك داون. I'm gonna write it. I'm gonna call it in this step we would like to make a comparison between the mass of CO2 emitted and the car mass or the car weight. تمام. This is my script. طبعا قلنا احنا if you want to enlarge this you use the function font. Just come here, write for example font like this, font size equal 4 or 5, okay 5, color green or green, yeah green, okay. I'm gonna do it like this. وهنا you should do an anti-slash to close يعني to be comprehensible. So anti-slash font like this. Now if you run it, it will appear like this. Now, this is my code, and here I would like to write that if the weight car less than the mass of CO2 emitted, so I would print تمام. I would print that yes, the mass of CO2 emitted per year weigh more than the car weight. ماشي. وإذا العكس أبغى أكتب شيء آخر. else print the assumption is not true. Okay, تمام. So if I run this، بالطبع إذا عندي خطأ حيظهر معي أنا. شو عندي هنا؟ line 1 probably because sometime in the syntax like this mass دقيقة هذه السنتكس ممكن كده صحيحة، لكن ممكن this value is not known. I should run this before. Okay, خلاص. Because I've made a change, but if your result is in different cells, you should rerun and you do an update فوق. لازم تسوي run من جديد حتى يحسبها، لانه هذه ما حسبها. Yeah, you can do it, but I prefer doing like so. هنا مثلا the print is like this. Imagine my consumption is less. مثلا اجي هنا عوض احط 12000 احط 8000. اجرب مره ثانيه. I'm gonna run it again. هنا كده ماشي، احط 6000. لين يعني فكرة ايش؟ انه الى حد انه الماس الايميتد تكون اقل. ماشي. هنا كم بالضبط؟ لسه 2502 صح؟ ماشي، خليني انزل كمان شوي. 4000. اوكي، ران. كم القيمة؟ لسه بعد. ماشي، خلينا ناخذ قيمة صغيرة مرة. This is the idea. If you write your code, you write it for the general situation. يعني you can apply it for many. This is the idea. هنا كم قلنا احنا 12,000. Okay, I'm gonna send you this like this. You will see how to. 48. انت الاكسجين 16. إيه بس احنا في كل الاحوال حسبناه كده 12 يعني to avoid any problem. So this is for the exercise one. I'm gonna pass to the next one. I can keep it like this. I can I already saved this one. I'm gonna create a new one, save as. I'm gonna call it exercise 2B. Remember, because I have another copy of the exercise, I don't want to overwrite the one I made by myself, and I would run this with you. So like this. اوكي، هذا اقفله الاكسرسايز 1، هذا اغير له اسمه اكسرسايز 2. تمام. يا هنا نيجي نشوف، هنلقاها هنا ترى هنا. اوكي، so this is it is the point 6. Okay, so wet processed phosphoric acid plants, the total fluoride emission standard is 10 gram per ton. في الاحوال احنا نعرف اكثر المتريك طن، يعني لما يكتب متريك طن هو بالنسبه لنا احنا الطن العادي ال 1000 كيلو جرام. metric ton of P2O5 feed. Okay, so when you take and you process 1 ton of P2O5, normally you should not generate more than 10 gram of fluorides. I'm gonna copy this and take it to my script, and look what I'm gonna do. I'm gonna come here at the end and put it with another color. So just to remember you, this is my standard. Okay, now what? A record? No, it's working. So هنا. Okay, so and I would like to this. I'm gonna copy this and here, this is the point number 6. I will keep the point just to remember you. So I would like to add the same size, and I will put my color equal to red. Okay, this is my I have a problem also. I'm gonna do it like this. Okay, so like this. Okay, this is good. Just because I would like to remember that this is the standard and I should fit with the standard. طبعا now if you run all this code, this step, I don't need it. I'm gonna remove it. I'm gonna remove all the mark. Okay, I would like to keep only this code. This is okay. Okay, so as we said, so your production, we said that you produce 120 gram of fluorides per, so your production, I'm gonna write that the production is 120. So this is 120 gram per gram of fluorides per ton of P2O5 feed. تمام. And the process of treatment should not emit more than 10 grams. But you are producing 120 grams. So what is the efficiency of your system? Is what you have produced minus what you should emit at the end of the system divided by what you have produced as polluted. يعني انت مثلا تنتج كميه معينه من الملوثات 120 جرام للطن من الماده الاوليه اللي انت بتاخذها من الارض، يعني تستخرجها من المنجم. تنتج ملوث كميه 120 جرام، لكن هي بتمر على نظام تنظيف، يعني غسيل للغاز وكذا، صح؟ there's a whole process. في النهايه بتتحصل على 10 جرامات ماكس. This is the standard. You should have this. Should not be more than this 10 جرام بير تون يعني as a production. ايش الافشنسي للنظام اللي عندك هذا؟ الافشنسي هو كم مسكت، صح ولا لا؟ ف 120 الا 10 هذا اللي مسكته وانت ما خليته يطلع برا، صح؟ مقسوم على القيمه الاوليه. فاحنا حندو we will do this. So the efficiency I'm gonna call it F. Efficiency of the system هي your production, okay, minus I'm gonna add هنا the limit, okay, the standard limit او سميها اللي تبغاها انت، اللي هي 10 okay. So this is the اللي هي هذه، تمام. okay. فهحط minus the limit divided بين قوسين by the production. Okay, I'm gonna print. You can write a string or print directly. It's up to you. The efficiency of the collection is F equal to هنا maybe it is better to add percentage like this, and for the value هنا I'm gonna write it dot 1F, and here format, and I would like to write that this is the efficiency ضارب 100. So if I run this, I'm gonna obtain 91.7%. Okay, I'm just here. Your result will be 0.917, but since you would like to present it as a percentage, it is better to write it like this. So this is. I'm gonna let you go at 9:15. Okay, I'm gonna take 15 minutes from you because we have a capstone at 9. But I would like to finish my one. So for this is this is very easy exercise. We will pass to the next one. Now this is exercise 2. I'm gonna finish it and pass to the. I'm gonna just make save as. You don't need to do like me. I'm, I'm writing save. So هنا for the exercise 3, I don't need, I should change this because we will work on NOx. So I will come back to my table of the standards. NO2, NO2, NO2. Where is NO2? Let's read the exercise before. So calculate the emission of NOx from all vehicles in Orange County, Florida in 2008. The fleet average NOx emission is for 2008 was 164 645 gram per mile, and the total vehicle mile traveled is 13.53 billion miles. Okay, so I don't need this. Okay, I'm gonna delete it. Run this. This is my script. So here, for example, I'm gonna write that I'm gonna keep the. So هنا. Okay, so in the exercise 3, so we have the emissions already. We have the emission, which is about 645 gram per mile. This is the emission of NOx. This is not the car consumption. You multiply this by the vehicle mile traveled by the vehicular fleet, and you obtain your result. So if you would like to write this correctly, we have the NOx, the vehicle mile traveled, since it is in billion miles. The total car NOx in kilogram per year. So that's why this is the emission cross VMT divided by 100, because I would like that the result would be in kilograms. So if I would like that my results would be in tons, so I'm gonna write like this, and this is the final result in. So is so the total NOx per year is NOx, and here NOx, just because we did modified the last exercise, and we do our calculations. We have a 22,000 tons to 56.8 tons per year. So this is for the exercise number 3, and thank you all. So now you should work the exercise number 4.